this one, yeah, I see what you're saying, that if we distribute that through, it doesn't seem like it's getting better, and I would agree. We could do that and still do the substitution I'm going to show you, but I don't think there's an advantage. Um, so let me actually just write out these two equations. We have P, I'm going to write my Q as a capital Q, just for the bit of dyslexia that I have. I don't do well with lowercase q's. And so here is Q, and then 5P minus 13 equals big number. So yeah, if we distribute that, that makes it worse. And I can't do any kind of elimination version of this because I'm not going to have the same variables. I guess I would have a 13Q there. I could multiply this one by negative 13, and I'd have a positive 13Q here and a negative Q there, but then I'm still going to get a mess here. So none of that I find very appealing. So since elimination is not looking good, I would go substitution. And as soon as these get a little complicated, substitution is often the easier way to solve. So for that, what I need to do is either get one of these equations, and it can be either one, as P equals a bunch of stuff or Q equals a bunch of stuff. So I either want to isolate P or Q, and then once I do that, I can substitute that expression into the other equation. So whichever one is harder is the one I would substitute into, because it is generally harder to get one of those isolated. If I tried to isolate that Q, for instance, I would have this 2827 over 5P minus 13, and now I have like an awful fraction. So that, again, not appealing. So I would come up here and I'd either isolate P or Q up here, and I could do either. If I'd isolate P, that looks a little easier. I add that Q over, and I would have Q plus 43. So then what I could do is I could take this right here, change color. Since Q plus 43 equals P, I could substitute that right there and then clean this up, and I would get a quadratic. The other thing I could do, and either one of these would be totally fine, is say I felt like I wanted to substitute for that Q because it's maybe a little bit easier on the substitution. So then if I brought the Q over to this side and then I subtracted the 43 over to this side, it would come out to P. Bringing that over would be a minus 43. Bringing this over would make a positive Q. And I did that in kind of the weird order so I could get the positive Q here. But now for that version, I have Q equals P minus 43. So I could also substitute that right there. So either solving this, and again, I would pick the easy equation to solve for the variable. So if I solve for P, I'd be plugging in here. If I solve for Q, I would be plugging this in there. I think either one is really pretty much, they both are going to suck a bit. I'm not sure either one of those is better than the other. I think I'll just go with the FOIL one, which was this one right here, so that I don't have to write Q's. So let me switch back to black. So substituting that in for Q, I would get what is still not a very pretty problem. P minus 43 is my new Q, and then that has to multiply 5P minus 13 equals this big old 2827 over there. So then we go P times 5P, so that's going to be 5P squared. And then on the outside, we'd have P times negative 13, so minus 13P. And then on the inside, I would have 43 times 5, so that's 215, I think. And then for that, I'm grabbing out the calculator. Let's check myself there. So 13 times 43. And that would be a negative and a negative, so that's going to come out to be a positive 559. And then that equals that 2827. So now let's collect our like terms. So 13 and that, so they're both negative, so I'm getting farther into the hole, so that'd be minus 228 P. And then I'm going to subtract this over, so 559 minus 2827, and that makes a negative 2268 over here, assuming I mashed all the buttons right on the calculator. So that's our quadratic. I would personally pass on trying to factor that, and I would just sort it in the quadratic formula. So that would give us P equals, so it's negative B, so negative of 228 would just be a 228, and then plus or minus negative 228 squared minus 4 times A is 5, and times C is that negative 2268. And then that's all over 2A, so 2 times 5, or 10. Let's see, so this will be P equals 228 plus or minus, and then I'm going to just throw all that in the calculator, and actually I will take the square root at the same time just because I'm going to run out of room. So careful when you throw this in, that should be a positive number because you're squaring the negative, so I would just type it 228 squared. And then this, when I type that, I'm going to just do plus that times that times that, because that double negative will make a positive, and it just makes the typing a little easier. So let me see what that comes up to. So under the radical there, I'm getting 97344, and then let's see what that comes out to when I take the square root. Answer, yay, 312. That means I probably did that right, because that wouldn't have happened on accident. So let's see, we got 228 plus, so it's going to, P is going, it's going to need to be a positive, because this is, yes, we're looking at demand function, so price and quantity. So we can ignore the, we're going to ignore the negative one because it's not meaningful to the context. So 228 plus 312 equals that, 450, and then divided by 10 would be 54 is what I'm getting for P. And then now that we know P, we can pop that back into either here, anywhere really. I'm going to pick the easy equation, which is where I solved it for Q. And then P equals 54 plus 43. And then that should be 97. Oh, excuse me, that is not correct. I know P and I'm looking for Q. So I should be putting it into this one. Sorry, I grabbed the wrong equation there. So P is 54 minus 43, and that will equal Q, and then 11 equals Q. So our P came out to 54, and our Q came out to 11. Cool, so hopefully that helped. It's, I think once you kind of get this solved for one of the variables and see the substitution, the rest of it is annoying but straightforward. You're just going to get it consolidated down to a quadratic, toss it in the formula, and kind of grind out the arithmetic from there. Let me know if you still have questions.